Welcome to Study Loop.
So we have this cone, it's inverted, so it's actually pointed down. So it makes sense that it's leaking there. And they tell you that the leaking rate, so that's dV dt, is, I would make it negative 10,000 cubic centimeters per minute. Now, what's happening is we're also pumping water into it. So I might do a C value that we don't know minus that 1,000. And then the tank has a height of 6 with a diameter of 4. So this is 6. All the way across is 4. So what that means is my radius is 2. And so we have similar triangles in here that the radius to the height is always this proportion of 2 to 6, which I could reduce to 1 to 3, which means that I can multiply the 3 over and the h over. But I'd actually probably rewrite this as 1/3 h, because when you go to the volume equation, which is 1/3 pi r squared h, I can replace the r in that problem with 1/3. So the volume is 1/3 pi, well, 1 squared is 1, 3 squared is 9, h squared times this other h is h cubed. And now I can take the derivative of this, where I multiply the exponent by the coefficient, and those cancel. 1/9 h squared dh dt. And then we know that the water level is rising, so we know dH dt is 20, 20, when the height of the water is, all of this is in centimeters, and then we had 6 meters. Okay, it still reduces the same way, but when the height is 6 meters, that means we are at 600 centimeters. So I need to have 600 squared. It's still fine that this is 1/9 though, because it still reduces. 200 and 600 still reduces to 1/3. Still pi. And then we're going to figure out the rate that it's being pumped in, and it's C minus that 10,000 that we had earlier. So I think all I'd have to do is add this 10,000 to the other side. And I can just plug into my calculator. Pi divided by 9 times 600 squared times 20 minus 10,000. And I got an answer of 250,250,274.123.